I'm going to be talking a bit about the mole and where it shows up in chemical formulas. So by now we may have heard of the mole. Chemists use a mole as a specified number of particles. So like if I have a sample of gas and I have another sample of gas and they're equally combining, I know the number of each by using something called the mole. This would be 1 mole of gas A. This would be 1 mole of gas B. Now, this mole is kind of like a dozen. So like if I say dozen, we think 12. When I say a mole, we think 6.022 times 10 to the 23rd. So let's make sure that we could write down this number. I want to gain practice so we could see it. So if I have a mole of pens, that means I have 6.022 times 10 to the 23rd pens. If I have a mole of paper, that means I have 6.022 times 10 to the 23rd sheets of paper. If I have 1 mole of Skittles, that means I have 6.022 times 10 to the 23rd Skittles. Now, what if I had 2 moles of atoms? Well, if 1 mole of atoms is 6.022 times 10 to the 23rd atoms, 2 moles would be multiplied by 6.022 times 10 to the 23rd for 1 mole. This was dimensional analysis from our last unit. I'm multiplying 2 moles times this, what we call Avogadro's number, and that's going to give me how many atoms there are, 1.2044 times 10 to the 24th atoms. I could do the same thing if I had 3.010 times 10 to the 23rd atoms. I'd have to divide by this Avogadro's number. By the way, I forgot to tell you, this is Avogadro's number. You may have seen that in a previous video. So what I would do here is I would do 3.010 times 10 to the 23rd atoms. If I want to know how many moles there are, 1 mole is 6.022 times 10 to the 23rd atoms. This is going to give me 0.5 moles. Now, I have some good news for you. We are not going to have to do these calculations this year. So I'm going to put an X here and say, not on the final, not for this year. So just a note when you're studying later, you will have to know that a mole is 6.022 times 10 to the 23rd atoms, but you won't have to do any calculations. Now, where does this show up in atoms? Let's look at a chemical formula. Let's look at C5H10O2. By now, with all of our work together, you should be able to look at this and say, oh, there's 5 atoms of C. There's 10 atoms of H. And there's 2 atoms of O. Altogether, there's 17 atoms total. Well, if I had 1 mole of C5H10O2, these atom words, I'm going to highlight them. These words atoms become moles. So if I had 1 mole of C5H10O2, then I would have 5 moles of carbon, 10 moles of hydrogen, 2 moles of oxygen. So I change those words. If I have 1 molecule here, I have atoms. If I have 1 mole, I got moles. Now it says how many carbon atoms are in 1 mole of this compound? It'd be 5 moles of carbon atoms. If I really wanted to calculate this, and this may be like an extra credit question, I would multiply this by Avogadro's number. 6.022 times 10 to the 23rd would give me how many atoms in total. But again, you will not need to know that for the final exam, and you will not have any calculations on that. We could do the same for hydrogen and oxygen, but again, I'm going to put an X here. And just write, I will have 10 moles of hydrogen, 2 moles of oxygen because of that thing, and we're not going to do any calculations with that. I'm going to end this short video here. This was a bit of a recap of a mole. If you are ever asked any questions about a mole, make sure you know how many atoms it is, and I could relate and represent the number of atoms using the mole.